Welcome to this new tutorial in the world of competitive karting. My name is Roman Tejador. We will talk about telemetry and data acquisition as scientific tools for optimizing performance in karting. Telemetry basically collects data from the karting as it moves. That is, telemetry is based on the quantification of the physical principles of movement. Now we will see the essential physical foundations for data interpretation motion. It is the change in an object's position over time. In karting, each lap is a succession of measurable movements. Position is the specific location of karting in an instant, which can occur in 1, 2, or 3 dimensions. Trajectory is the continuous path that the kart describes on the track, resulting from the sequence of positions, that is, the line that the kart forms with its successive positions on the track. Distance. Total amount of road traveled by the kart, regardless of direction. Displacement. Net change in position, useful in partial sectors. Speed. Scalar magnitude that indicates how fast the kart is moving. Distance over time. Speed. Vector magnitude that, in addition to speed, includes the direction and sense of movement. Acceleration. Longitudinal. Measures the acceleration or deceleration experienced by the driver and the kart in the direction of movement, e.g. braking or acceleration. Normal or centripetal acceleration. Lateral. Measures how much the direction changes. That is, it measures the acceleration experienced by the driver and the kart when taking a curve, for example. These parameters are detected by accelerometers and GPS sensors, and understanding them is vital for analyzing data graphs. How to read the data. We read them both in numbers and in XY graphs, called Cartesian axes, where the x-axis represents time, seconds, or distance, meters. The y-axis shows the channels, speed, RPM, percent brake, g-force, etc. Why use distance on the x-axis? Because it allows you to compare 2 different laps in the same physical position on the track, regardless of the total time of each. You can see it meter by meter. Here he braked earlier, here he accelerated a little later. Look at the line he used in this specific corner. If you compare by time, imagine 2 laps, 1 a second faster. Braking at the same spot on the track will appear at different times on the graph. Everything would be out of sync. It would be a mess to compare. That's why you compare the action at the same spot on the track, not just the final time. You compare technique in every meter, not just overall times. It's a complete change of perspective for analysis. It's like seeing the exact brush stroke in a painting, instead of just seeing the time it takes to paint. Well, now we will see what exactly a modern system like the Micron 6 with internal multi-band GPS measures. These systems record a lot of useful channels. It measures, well, the basics, GPS speed, which is the actual speed, not an estimate. The position, longitude and latitude, which are the coordinates, of course, to draw the line on the circuit map. But what is really interesting are the g-forces, the longitudinal g, which tells you how hard you are accelerating or braking, and the lateral g, which measures grip, how much force the kart is taking from the side and the corner. GPS slope is recorded if the track has inclines or descents, the altitude as well, and a very interesting one, the GPS radius. GPS radius, what is that? It measures the radius of the curve the kart is tracing at that moment. It's an objective measure to see if a driver tends to take turns wider or tighter than they should, perhaps without realizing it. That's great. Being able to measure the actual trajectory, not just the one you think you took. There's also some rotation. The GPS gyro measures the speed at which the kart rotates on its vertical axis. It's great for objectively detecting when the car is going nose first, understeer, when it's not turning, or when it's going tail first, oversteer. It's not enough to just look at the cold data. Data is a powerful tool, yes, but it requires context. Objective telemetry must be compared with what the pilot felt, with his subjective perception. What did you feel? Where do you think you went wrong? Exactly. That combination is what really works. There's a technique he suggests, asking the driver to draw their lap on a map, marking where they brake, where they turn, where they accelerate, based on their feelings. And then, of course, you compare that drawing, which is subjective, with the actual data from the GPS and sensors. Right there. That's where the surprises arise. What you feel matches what the machine records, where it doesn't match. Let's see an example. Imagine a driver feels like they're entering turn 3 too slowly. They think they're braking too early. But you look at the data overlaid with a fast lap and see that they're braking at exactly the same point. The problem is that its minimum speed in the middle of the corner is lower. In other words, the problem wasn't the initial braking. Maybe not. Maybe it's because he hesitates for a moment in the middle of the corner, or he takes a less rounded line that makes him lose speed there. The data tells you where the difference really lies, beyond the initial sensation. It's a dialogue between what you feel and what the devices measure. How powerful. Because we've all had that feeling of, I think I'm failing here, but the data might tell you, no, look, it's a little further. And to see all this together clearly, analysis software, like that's why the pilot engineer or pilot analyst dialogue is important. And to visualize all of this, well, there's specific software. Race Studio 3. What does this software allow you to do? It lets you download everything and view graphics, compare laps, even compare drivers, overlay lines on the map, and divide the track into sectors to analyze specific sections. And something very powerful is to synchronize the data with a video on board. See the numbers and the image at the same time. It's incredibly useful to understand what exactly was going on when the data shows something strange. Key recommendations, a couple of practical things. First, always analyze by distance, as we said. Second, always cross-reference the data with the pilot's feelings. And third, something basic but vital, make sure the sensors are properly installed. A failure, for example, in cables, false contacts, when reading data is very difficult to detect. A well-used data logger changes karting. It takes it beyond pure trial and error from mere feelings and leads to evidence-based decision-making. It's physics, perception, and data all rolled into one. Knowing how to read that is what makes the difference. And it leaves us thinking, if we can analyze every meter of a karting track with this level of detail, what couldn't we learn if we applied such precise measurements to other sports, or even to complex tasks in our daily lives where every move, every decision counts? It's a thought worth pondering. Well, we'll hear from you next time.